Hello everyone, let's have an overview of Bayesian inference. Bayesian inference provides a systematic way to update our beliefs, represented as probabilities, in light of new evidence, which is data. The core idea is based on Bayes' theorem, which can be expressed as following. So we have probability of theta given certain data equal the probability of that data based on that theta or hypothesis multiplied by the probability of theta divided by the probability of the data itself. So theta here represent the parameters or hypothesis which we are trying to infer. D represent the observed data. Okay. B, probability of theta, it is the prior distribution, our initial belief about theta before seeing data. Now, the probability of the data given theta is the likelihood, the probability of observing the data D given a particular hypothesis, theta. The probability of D, which is the marginal likelihood or evidence, normalizing constant, ensuring probabilities sum to 1. And finally, the probability of the theta given D is the posterior distribution, our updated belief about after observing data. So that's what we need to calculate actually, the posterior. So we have the prior, which is our initial belief, and we want to see after having new data or evidences how that initial belief has changed. So this is the idea of the Bayes theorem. Now, how to do it? There's key steps in Bayesian inference. First of all, we need to specify the prior probability of theta. Begin by starting your assumptions or beliefs about the parameters before looking at the data. So any problem you want to solve with Bayes rule or Bayes theorem, first of all, you need to find the prior. You need to have this starting point, the initial belief. Then, compute the likelihood, which is the probability of D given theta. Determine how likely it is to observe the data D if hypothesis theta were true. If theta were true, what will be the probability of the data you have now? Okay, so this is the likelihood. So after that, after doing this, we need to apply Bayes' rule. So what we have to do simply is to multiply the prior by the likelihood to get a normalized version of the posterior. Okay, this is unnormalized. Now, if you want to normalize it, all what you have to do is to divide by the marginal likelihood. Okay, so these are the steps to compute Bayesian inference. First of all, you should need to have the prior, then you need to compute the likelihood, then you multiply them together, then you will get a normalized posterior. If you want to have a normalized one, then you have to divide by the marginal likelihood. So let me give you an example. Suppose you are given a pair of digital calipers that measure lengths in millimeters, but they are miscalibrated by either -1 millimeter or +1 millimeter. There is no reason to believe one outcome is more likely, so each has a prior probability of 0.5. So both of them, any caliber, could have -1 millimeter or +1 millimeter by a chance of 50%, equal chances of getting this or that. This is our initial belief, as you can notice here. So each has a prior probability of 0.5. The standard deviation of the measurement error is 1 millimeter. Keep that in mind. We test the calibers and obtain measurement that is 0.5 millimeter larger than expected. So it could be, if it +1 millimeter, that means our measurement was 1.5, and if it was -1, it will be -0.5 millimeter. Okay, so given this evidence, what is the probability that the calibers are off by +1 millimeter? So our initial belief is 50%, 0.5. But how this will change after this measurement, that's what we need to understand. So to solve this, of course, we will apply Bayes' rule. First of all, let H plus be the hypothesis that the calibers are off by +1 millimeter. and H minus is the hypothesis that the calibers are off by -1 mm. So what are the prior probabilities? The probability of having calibers off by +1 mm, as we said before, is 50%, which means 0.5, and the same thing for also -1 mm, which is 0.5. Now after that, that was our first step to specify the prior. Now we have the prior, let's go into the likelihood. So to estimate the likelihood, okay, we need to use the normal distribution here. So the likelihood is the value of the normal distribution function at this point. But remember that sigma equal to 1. This is the standard deviation. So we can calculate sigma here. So after that, what is the likelihood if calibers are +1 mm off? So the data we have is 0.5. So we substitute this, and what we will get this result. Okay, and in case if it was -1 mm off, we will also get this result. So the posterior, this is what we need to estimate finally. The posterior probability using Bayes' rule will equal, as we said before, the prior multiplied by the likelihood over the probability of data itself. So what we realize here, that the probability of having +1 mm off, or having -1 mm off, is equal. So here we have 0.5, here we have 0.5, here we have 0.5. So we can cancel those. Mathematically we can cancel them. So if we want to simplify the this expression, what we will get, we'll get that the posterior will equal the likelihood over the likelihood plus the likelihood of the if it was calibrated by the miscalibrated by -1 mm. طيب, numerically it's obvious that it's for the likelihood of +1 mm it will be 0.8825, and for the -1 mm it will be 0.3247. Okay, we can summate them. So we have this expression here, summation, and then we will do the division, and the answer will be 0.731. So actually the probability of having a caliber miscalibrated by +1 mm has increased into 0.73, especially after the final measurement, which was 0.5 mm extra or above the expected. Okay, thank you very much. I hope you have enjoyed.